Okay, I'm going to go over the unit review for trigonometry. And now your questions will look identical to these with different numbers, but it should follow the same process. Okay, problem number 1. Go ahead and put, this is the answer key right here. Okay, problem number 1, I noticed right off the bat this is a special triangle, okay? We call it a 45, 45, 90. Now the model for a 45, 45, 90, if I were to do a quick sketch of it, looks like this. These two sides have to be the same measure, and I could do the Pythagorean theorem, or you just have to know that the model is x times the square root of 2. So if this is 60, then down here this has to be 60, which means, again, I could use the Pythagorean theorem, but it's much easier if I just follow the model. So 60, 60, and right here this would be 60 times the square root of 2. And I can just leave it like that, okay? So it says simplify your answer, typed in exact answer. If I wanted a decimal answer, it would say exact and it would tell you to round. And it also says use radicals as needed. Square root is the radical sign. Okay, next one. Again, it's our other special triangle, 30, 60, 90. This is what the model looks like. Okay, our short leg is x, our hypotenuse is always twice as big, and the long leg is the weird one. And it's the square root of 3 this time. Okay? So, if I know the hypotenuse here, and again, just looking at my model, the relationship between the hypotenuse and the short leg is the hypotenuse is double or the short leg is half. So that means I could go ahead and put a 12 right here. And if you look at my model here, again, I could use the Pythagorean theorem, but it's much more work. I'm going to plug in 12 times the square root of 3. Now be careful, make sure you put the right thing in the right spot. So let me move these a little bit. So y was the one with the square root. So this is 12. This is 12 times the square root of 3. Okay, moving on. It says write ratios. The word ratio is a fancy word for fraction. So all of these answers are going to be fractions. Now you might need SOHCAHTOA in this. I'm going to go ahead and write out SOHCAHTOA. And SOHCAHTOA is the acronym that helps me determine which sides I'm using here. So I'll go ahead and identify my reference angle. So all of these say angle M, M, and M. So this is my reference angle. I'm going to start naming some sides. Across from the reference angle is called opposite. Right next door to the reference angle is called adjacent. And always across from the 90 degrees is my hypotenuse. So this is height. Okay, when it says sine, okay, the SO part of SOHCAHTOA tells me it's sine. And the O and the H, okay, if I look up there in my diagram, the only names up here that have an O and an H in it, are opposite and hypotenuse. So the OH tells me it's opposite over hypotenuse. Okay, so I'm going to do 2 times the square root of 7 over 8. It says simplify fractions. Again, type in exact answers. We do not want decimals. The only thing I could simplify is right here. Ignoring that square root of 7. 2 over 8 does reduce to 1/4. So if I were to simplify this, my final answer would be square root of 7 over 4. Now technically I could have a 1 here, but I don't need it. Oops, let me try that again. Okay, cosine. When I look up here at cosine, the ca, I notice adjacent over hypotenuse. And my adjacent is 6, and my hypotenuse is 8. Now this one doesn't have a square root, but if you type this in, you'll probably get it wrong because it's not reduced. Okay, 2 goes into both of these numbers. 2 goes into 6 3 times, 2 goes into 8 4 times, and there's my final answer. Okay, I'll go ahead and circle my final answers here. So this is the sine, this is the cosine, and then last but not least, tangent. And if I look up here, I notice tangent is opposite over adjacent. And in this scenario, it would be, let's change my color up here. So opposite is 2 times the square root of 7. Adjacent is 6. And again, just like the sine up above, I could reduce this to 1/3. So my final answer would be square root of 7 over 3. And here are my 3 ratios. Okay, let's get down to the important questions. Can you use trig or SOHCAHTOA to solve these problems? So SOHCAHTOA. Okay, this is my reference angle. I'm going to start naming some sides. This across from my reference angle I call opposite. Right next door to my reference angle we will call adjacent. Now on this particular problem, you'll notice across from the 90 degrees is hypotenuse, but I'm not going to put the word hypotenuse. I'm not looking for the hypotenuse. I don't know the hypotenuse, so the hypotenuse is insignificant to me right now. Now I just have to determine which of the 3 trig ratios I'm going to do. And I look up here, and the only one that has an O and an A in it is TOA, and the T stands for tangent. So I'll put, maybe I'll do my work down here at the bottom. So the tangent of 31 degrees equals, and this is important, you have to have the right thing in the right spot, okay? It's either 46 over x or x over 46. And when I see O and A, it tells me it's opposite over adjacent. Now, there's multiple ways to solve this. I think the easiest, again, remember, this is a number. It's a pre-programmed decimal in my calculator that represents a ratio that works for every triangle that has 31 degrees. Doesn't matter how big or how small. Whatever the opposite over adjacent is, I keep getting the same number. Okay? I'm going to turn that number into a fraction. This is called a proportion. Okay, the way we solve proportions is we cross multiply. And we would get x times 1 equals. Now, anytime we're multiplying numbers like as in 46 and trig names, I like to put the number first and the trig name second. And this is how you'll see it in most books. Now, the reason this is better, it's mostly a calculator thing. Okay? I don't even need to put multiply. Any calculator will multiply for me. A lot of calculators want to add a set of parentheses. And if you move this over here and you have this, it's going to give you the wrong answer. Okay? So, and you can do this on Desmos, or you can do it on any graphing calculator. On the graphing calculators, if it looks like this, you could just leave the parentheses there and it would make a difference. So we always write it this way. So let me get my calculator out. Okay, step 1, you got to make sure you're in the right mode. If you're on Desmos, the default is already degrees, so you're good to go. But if you have a graphing calculator like mine, you have to hit mode and you have to make sure degree is highlighted or all your answers are going to be wrong. Okay, now I just type it in the way it looks. 46 tan of 31. Okay, here's a perfect example. I didn't close my parentheses. I could have also closed my parentheses. And it doesn't matter. Either way, I'm going to get the right answer. And there's my answer. So let me type it in one more time. 46 times the tangent of 31. I like to close my parentheses because it looks a little nicer. I'll pull this over. Now, this is a computer program, so you have to round appropriately. Okay? If you don't round appropriately, it's going to mark you incorrect. So might as well round appropriately. So nearest hundredth. Hundredth is 2 decimal places. okay? And I did have to decide, is it 0.63 or 0.64? And I look over here to the right. Since that's a 9, I'm going to bounce it up. So x is approximately equal to 27.64. Okay, let's go on to the next problem. Okay, same problem. I'll go ahead and put SOHCAHTOA right here. Here's my reference angle, 40 degrees. I'm going to name some stuff. This over here is opposite. Okay, across from the 90 here is hypotenuse. You'll notice I'm not even going to put adjacent. I don't know adjacent. I'm not looking for adjacent. We don't care about adjacent in here. So looking at the term SOHCAHTOA, I notice O and H. The S tells me I'm going to use sine. So let's write it out. The sine of 40 degrees equals. Okay, and you have to be very careful. It's got to be opposite, which is 22, over hypotenuse, which is C. I like to turn these into proportions. The way we solve for proportions, just like we did in the last unit, is we cross multiply. Now, this problem's not done. Okay, the last problem, when I cross multiplied, I had my variable all by itself. But in this problem, I get C times the sine of 40 degrees equals 32. You'll notice my variable is not alone. But you also have to remember, this is a pre-programmed decimal in my calculator. It's a number. The opposite of multiplying by that number is dividing. So sometimes I use division, and sometimes I use multiplication. So this would be a division scenario. So if I do it on one side, I have to balance out my equation and do it on the other. Okay, now it's a calculator problem. Let's clear this out. 32 divided by the sine of 40. Enter. Okay, let me shrink that up. I'll move it over here. Maybe. Okay, we do have to round appropriately. Again, the nearest whole number this time. So you have to decide, is that going to stay a 49 or is it going to turn into a 50? And again, I look to the number to the right, and the 7 tells me to bump it up. If it's 4 or below, it stays the same. If it's 5 or above, it bumps up. So this would be 50. Okay, I'm going to use SOHCAHTOA right here for this problem. I meant to erase that, but here, let's move it over here with my reference angle. Come here. Maybe. That works better. Okay, reference angle. I'm going to call B here adjacent, right next door. I'm going to go ahead and call C here, which is across from my 90-degree angle, hypotenuse. Okay, I look up here and I see I have A and H, which is the ka of SOHCAHTOA, and that is cosine. So the cosine of 30 degrees equals, okay, adjacent over hypotenuse. So B over 290. Now, again, when I cross multiply, sometimes I'm done, sometimes I have to do more. Sometimes it's a multiply scenario, sometimes I have to use division. This is a multiply scenario. You'll notice, if I multiply the orange stuff, I just get B. If I multiply the yellow stuff, I get 290 times the cosine of 30. Okay, let's use our calculator. Clear 290 cosine of 30. And I get this. Let me pull it off here and shrink it down a little bit so it's out of my way. And maybe I'll slide it right there. Okay, again, round to the nearest whole number. Just to the right of the decimal is a 1, so that's going to stay 251. Okay, down to problem 7. All right, these next 3 problems are different. The last 3 problems I was looking for sides. You'll notice the next 3 problems, even though it's in story problem format, I'm looking for angles. But I am still going to use SOHCAHTOA, so I'm going to pull this down. Okay, and I'm going to name them just like I did before. This is across from my reference angle, so I'm going to call it opposite. This is right next door to my reference angle, so I'm going to call it adjacent. And I'm not going to put in hypotenuse. So looking up here, the only one that has an O and an A in it is TOA. So it tells me I'm going to use tangent. The tangent of. Now, in the last 3 problems, I was putting a degree measure here. I don't know the degree measure. So I'm going to put a variable, x, equals. And I'm going to leave a little space here, and I'll show you why in a second. Opposite over adjacent, 9 over 8. I'm just going to leave it like this. Now, how do I make this go away? I'm not done with this problem. My answer is not 9/8. That's way too small. I would like to get x by itself. Okay, the opposite of tangent is called tan inverse. So I'm taking the tan inverse of this side, and I have to balance out my equation. If I do it on one side, I have to do it on the other. These cancel each other out. Boom, boom. Okay, now it's a calculator problem. If you're doing this on Desmos, you would have to hit the function button in order to see the inverses pop up. If you're doing it on a calculator like this, you have to hit second, and I see it in blue, right above tangent. And I just type it in the way it looks in the calculator. Enter. All right, there's my answer. Oops. Get rid of this. Let me undo that. Let me shrink this thing down a little bit. I'll put it right there. Okay, it says round to the nearest degree. That means whole number. So I look here and I notice 48.3. I could care less what's beyond the 3. Okay, so that's just 48 degrees. Be careful, it says do not include the degree symbol. Just type in the number. Okay, I'm going to pull SOHCAHTOA down again. I'll put it right there. I'm going to name some stuff. This is opposite. Okay, this across from my reference angle is hypotenuse. I'm looking at SOHCAHTOA. The only one with an O and an H in it is the SO. So that tells me I'm going to use sine. So the sine of x equals, I leave a little space. Okay, opposite is 7, hypotenuse is 13. Now usually when I do this in my class, the first couple times I'll show up there how it cancels, but then I'll start going like this. Hey, if I take the inverse on the left side, it goes away. But that means I have to do it on the right side. Okay, now it's a calculator problem. Clear this out. Second sine of 7/13. Enter. Shrink this down. Okay, again, look what they're asking for. It says they are round to the nearest degree. So that's whole number again. Okay, this is one that's going to bounce up. So again, I look to the right of this line. 5 or above goes up, 4 below stays, leave it alone. So this is just 33. You'll notice this one has the degree symbol on the outside. Do not include it. Okay, let me pull SOHCAHTOA down here because we'll use it again. Okay, if I started naming sides, this side is right next door, touching my reference angle. It's adjacent. Across from my 90 is called hypotenuse. Looking at the acronym SOHCAHTOA, I noticed the only one with the A and H in it is the CA, which stands for cosine. So I'll do my math over here. The cosine of, now, this is a weird variable. It's called theta. We use it often in math to represent angle measures. No big deal. It's the Greek T in the alphabet. Just treat it like an X or any other Y, any other variable you want. I'm going to fill in my fraction, though. Adjacent is 60. Hypotenuse is 84. If I take the cosine inverse on the left side, it goes away. And I have to balance out my equations. Okay, calculator problem. Move this over here and get it out of the way for now. On, clear. Okay, second cosine of 60 divided by 84. Enter, and we get this. And since this is the last problem, I'll move this down here, get it out of the way. Boom. Okay, round to the nearest degree. So again, nearest degree means whole number, and the 4 tells me I leave it alone, 44. Okay, let's go on to the next problem. Problem 10. Okay, I notice this one, I'm not using inverses. I am going to look for a side. So let me go back and steal the word SOHCAHTOA. Actually, well, let's just leave it there. I'll rewrite it. It's easier than moving it. So again, SOHCAHTOA. Okay, here is my reference angle. Name stuff again. This is across from it. We're going to call it opposite. This is across from my 90 degrees. We will call it hypotenuse. Okay, the only one up here that has an opposite and a hypotenuse is sine. So the sine of 3 degrees equals 700 over c. Okay, turn this into a fraction on the left, cross multiply. Now you'll notice again, sometimes we're done, sometimes we're not. This one is one where we're not quite done at this point, because c is not alone. C is being multiplied by this decimal in our calculator, right? The opposite of multiplication is division. And I don't like changing sine of 3 into a decimal because you would have rounding error. I wait to the very end. This would be a division problem. So I'll get my calculator out. I'll move it over here. And I get 700 divided by the sine of 3. Enter. And I could probably slide it right there. That'll work. Okay, round to the nearest foot. Again, whole number, so be cautious that you're answering the way they want. Now, this is a big number, okay, but I'm dealing in feet, and we're talking about a plane taking off. So this would be 1, 3, 3, 7, and the 5 stays alone. Okay, cofunctions. Now let me talk about cofunctions a little bit. So if I were to make a triangle here, And if this were my reference angle, let me highlight here. And for example, if it says cosine, so cosine right here would be adjacent over hypotenuse. Now a cofunction is, well, how would the names change? It does say 41 degrees, so I guess I can put that in there. The cofunction is, well, what would happen if I went up here and looked at this angle? Now, if this is a 90-degree angle, which it is, okay, then that means we know all triangles, let me get rid of this, and I'll move this back. All triangles add up to 180, so that means these two angles here, the orange and the yellow, have to add up to 90, okay? So if that's 40, then this one has to be 49 degrees. Now, if I didn't look at the adjacent here, if I'm looking at the other angle is what I meant to say, this is no longer the adjacent. Now this is the opposite. An opposite in hypotenuse just happens to be a sine problem, okay? And so my answer here is C, sine of 49, and I'm saying it's equivalent to 41. There's a quick, easy way to check that. So we have a calculator here. Let's check. The cosine of 41 happens to be that decimal, which represents a ratio. The sine of 49 gives me the exact same answer. Okay, so C is my correct answer here. Okay, we are jumping into the last lesson with area and the law of sines and cosines. And the area formula for this one, and this is very formula driven, these last few problems, looks like this. So 1/2, and then it says B times C and the sine of big A. Okay, but anytime I have this scenario like this where it's a not right triangle, okay, this formula will work, and all of this is derived from right triangles, but let's just follow the formula. Okay, if I have what's called a side angle side scenario, where I have a side and a side with an angle in between. So this would be side, angle, side. I'm going to fill in these numbers, okay? So obviously the big A is the angle, so the 44 is going to go right here. And then we've got these two sides, and I don't care which one's B or which one's C. So maybe I'll put 17 right there, and maybe I'll put 14.5 right here. Okay, so if I were going to write it out, 1/2 times 17 times 14.5 times the sine of 44. And now it's a calculator problem. So let me get my calculator out. On, clear. Okay, so 0.5 or 1/2, 17. You could also use the dot for multiplying 14.5 and sine of 44. Oops, let me fix that. 44, and here's your answer. Round to the nearest tenth. So let me pull this off. Let me close that. Let me move this off to the side. Okay, the tenth is 1 decimal place. Okay, and that's going to be 85.6. Okay, this next problem, it says law of sines. Let me write the law of sines real quick. Okay, the law of sines looks like this. And these fractions can be flip-flop, but I believe that this program or the textbook we use here writes it out like this. So sines with the big letters on top, little letters on bottom, and there's 3 fractions here. And again, all of these can be flipped. The math works out the same. Now, when I do these problems, I will only focus on 2 fractions. So for example, maybe I'll focus on these ones, or maybe I never focus on all threes, or maybe the A's and the C's. I'm just going to start filling in what I know. Now, when do you use the law of sines versus the law of cosines? And that's an equals right there. Anytime I know an angle and a side opposite, okay, I'm going to do the law of sines. Now, when I first look at this, first glance, you might say, well, angle, I don't know that, darn it. And angle, I don't know that. And well, I know this side, but I don't know the angle. But I can find this angle real quick, right? Because all triangles add up to 180, okay? So these two, if I add 40 and 64, I get 104, okay? And that means this angle right here has to be 76 degrees. Okay, now I have an angle and a side opposite. And you notice I have big A and little a, so I can fill these in. Big A, little a. Okay, and I am looking for, let's do B first. So little b, I'll highlight, excuse me, and I know what big B is. It's that right there. I'm going to fill these in. So for this particular scenario, I am only going to focus on this ratio right here. Okay, so I'm going to redo my math over here on the right. Let me get rid of some of this stuff. Yeah, I'm okay. Let me put that back. Okay, so over here to the right, I get sine of big A, which is 76 degrees, over 14 equals sine of 64 degrees over B, which I'm looking for. Okay, just like we've done in the past, this is a proportion. I'm going to cross multiply. This times this equals that times that. I get B times the sine of 76 degrees equals 14 times the sine of 64. And now I have one step left. I need this to go away. The opposite of multiplying is dividing. I'm going to divide the left side, and I would do the same over here and balance out my equations. Okay, now it's a calculator problem. Okay, I do have to be in degree mode, and I'm going to type it in exactly the way it looks. So 14 sine of 64. Do close your parentheses here, divided by the sine of 76. Enter. And there's my first answer. Round to the nearest tenth. This one's a little weird because it says 12.96, and that 9 is going to turn into a 0. So for this particular one, I would type in 13, and I would put 0.0 here just so it knows you rounded correctly. Okay, next one. I'll do the same math on this one. So now, again, I'll do my math down here. I'm going to stick with the big A's. So sine of 76 over 14 equals. Now it's like I'm ignoring the middle stuff, and I'm going to the C's. So I will highlight C's in purple here. Here's big C, and I'm looking for little c, and that will go here and here. So I get the sine of big C is 40 degrees, and just like we did before, cross multiply. So this times this equals that times that. I get C times the sine of 76 degrees equals 14 times the sine of 40. And again, it's a division problem. Divide. I have to cancel it out over here, balance out my equations. This goes away. Okay, now it's another calculator problem. I'll do it all in one spot. So on this one, I will do 14 sine of 40 close your parentheses, divided by the sine of 76. Sorry about that. Okay, here's my two answers. I'm going to pull them down. I'm going to scroll down and get them out of the way here. And again, it says round. I might move this stuff over to the nearest tenth. So on both of these, that was my 13.0, and this one would be 9.3. Okay, next problem. Okay, on this one, law of cosines or law of sines, which one to use? Again, I always use the law of sines if I know an angle and a side opposite. Okay, nope. And I know this side, don't know this angle, and there's no easy math I can do to find it. And same thing here. So if this is the case, okay, I have to use the law of cosines. Now, I'm going to pause real quick and I'll come back. I'm going to snip a picture of the law of cosines because it's a little complicated if you look it up. So let me pause here for 1 second. I'll be right back. Okay, this is what it looks like. Now, this looks like a jumbled mess and it's very confusing. Okay, but all of these are the law of cosines. Okay, but I never use all three. I only use one. Now, if I had a triangle that said A, B, and C, okay, then I would just choose which one am I looking for. And it really doesn't matter, like if for example, let's say this was big A, this would be little a, okay? And then maybe this is little b, and this would be big B. And maybe this is little c here, down here, and this is big C. Okay, and then I just look up here, well, which one do I use? I like the one right here, the bottom one, because it's the only one that has big A in it, and I know big A. So all I'm going to do is plug the numbers in the appropriate spot. So I get A squared equals, B squared is 28, so I'm going to plug it in, plus C squared is 26, I'm going to plug it in, minus 2, that's always part of the problem. 28 is B, 26 is C, and then I'm doing the cosine of 35 degrees. Now, I do have to get rid of this, so I like to type in one shot in my calculator, and the opposite of squaring something is square rooting. So I'm going to do one huge square root over the whole thing. So let's type that in. All right, so let me clear that out. So big square root, and I'm going to let this thing just keep growing and growing. 28 squared plus 26 squared minus 2. You can use parentheses or the dot, it doesn't matter, times 28 times 26, the cosine of 35, and I like to close my parentheses. Enter. And there's my answer. Okay, let's see what they want us to round to. It says, I have room right there, sure. Do not round your final answer to the end. That's why I did it all in one shot, to the nearest tenth. Tenths right there. So this would be 16.3. Okay, I'm also going to pull this down again. Or maybe I will copy it. Edit, copy, and let me paste it down here. All right, this one's a little more intense, okay? Let's start with big A. So I'm looking for big A. And I notice the only equation I have up here is that has a big A in it is the bottom one. So I'm going to use this bottom one again. I am going to name some stuff. So this is little a. And this is across, so this is little b. And the last one, this is little c. Okay, I'm going to plug in all the variables I know. And I'll do that right here. Let me move this up a little bit. Okay, so this time I don't have a by itself, so I know what a is. It's 4 squared. B is 2 squared. Whoops, I should put equals there, excuse me. 2 squared plus, here's c, minus 2, and b is 2, and c is 5, and then I've got cosine big A. Okay, I've got to do a little bit of algebra here, okay? Now on my algebra, I got to move some of this stuff over, because my goal here is to get A all by itself. So I'm going to start by subtracting this and this. So I'm going to subtract those both and move them to the left. Some people like to turn these into numbers. That works as well. Maybe let's do that. That might make life a little bit easier. So this is 14 or 16, excuse me. This is 4 plus 25 minus 2 times 2 is 4 times another 5 is negative 20. So I'm just kind of shrinking this down right now. So I get 16 equals, when I add these together, I get 29 minus 20 cosine big A. Okay, so step one, I'm going to subtract 29 from both sides. Minus 29. Okay, this goes away. Now I get negative 15 on the left side, negative 20 times, I'm going to put a dot here because it's important, the cosine of big A. Okay, the dot means multiplication. The opposite of multiplying is dividing. So I need to divide both sides by negative 20. This will go away on the right. And you can reduce this. You can leave it as a fraction. You could change it to a decimal. It doesn't really matter. I know that 5 goes into both those numbers. And this is going to reduce to 3/4. And I get something that looks like this. Cosine of big A. Now, we had this problem earlier when I'm looking for an angle measure. Okay? The way I make this go away is I take the inverse of this number. Okay, if I did the inverse on the right side, cosine would go away. I do it on the left side. Now it's a calculator problem. So I'm going to turn this on, clear. I get second cosine of 3/4. And there's my answer, 41.4. And that's for big A. So big A is 41.4 degrees. And I'm actually going to fill that in up here. 41.4 degrees. Nope, wrong spot. Let's fix that. I've already got a number there. I want an angle. Okay, now you could do the Pythagorean theorem again, but I would now jump to, or excuse me, the law of cosines, but I'm going to jump to the law of sines in this one. So again, my law of sines problem is sine of big A over little a equals sine of big B over little b equals sine of big C over little c. And maybe we find big B this time, okay? So I'm going to use these two parts. And I'll plug in the A's first. So this is a separate part of my work here. I get the sine of big A, which is 41.4 degrees, over little a, which is 4, equals the sine of big B, which I don't know, over little b, which is 2. Okay, I'm going to cross multiply. This times this equals that times that. So I get 2 times the sine of 41.4 degrees equals 4 times the sine of big B. All right, I would like this 4 to go away, so I'll divide each side by 4. Okay, let's figure out what this number here on the left is. So I'm going to use a calculator here. This is a pretty lengthy problem here, so let me clear this out. 2 times the sine of 41.4, close your thing, your parentheses, divide by 4, and I get this. Now that's not my answer, okay? So I got the sine of b equals that decimal, 0.330659. That should be enough decimal places. And just like we did last time, the way I make this go away is inverse. So I'm going to take the sine inverse of this number. So second sine, second answer, and there's my other angle, 19.3. So big B is approximately equal to 19.3. Put that up here. Okay, then last but not least, I am not going to use any hard math because we should know that all angles add up in a triangle, add up to 180. Okay, so now I'm just going to use my calculator here, and I will use some basic subtraction. So 180 minus 41.4 minus 19.3, and we have our final answer. 0.3 degrees. Now, on these problems, don't be confused by the picture, okay? Because when I look at this, you're like, 119.3, this is not drawn to scale, so don't panic, but that's how you do the math.